Hello, today's lesson is 7.3, solving equations using multiplication and division, and this is part 3. The emphasis is going to be on writing equations based on word problems. So we're going to be translating words into math. We're going to solve them and then check our solutions with substitution. So here we go. Well, first of all, you should note that these are in your record and practice journal on page 159. So you don't have to write them down separately. If you just want to get your record and practice journal, you can work along for the next couple of problems with that. So notice we have an area, we have a rectangle. So we know that the area is 24 square units, and then the length is the part that's unknown, and the width is 6. And so remember, the area of a rectangle is length times width. So what I'm going to do is I'm going to fill in the information that I have, and if I know the area is 24, then instead of A, I'm going to write 24. My length is what is unknown, and they gave me an X, so I'll just go ahead and use an X for the length, and then it's times 6, because I know the width is 6. So this is an equation that has one variable. I look at the side with the variable, and I'm trying to undo the operation. The operation is multiplication, because that's how you find the area of a rectangle. So I'm going to draw my balance scale here, and I'm going to show that I'm dividing with a fraction bar both sides by 6. I can cancel out the 6 and the 6. Remember, they make a giant 1. And then 24 divided by 6 equals 4. And all I have left on the other side is x. So I know that the length of the rectangle is 4. And because they don't give me any units except for just the general units, then I'm going to say x equals, or I can keep in my 4, I can say x equals 4 units. Now, of course, I'm going to check my math by plugging it into the equation. 24 equals, instead of the x, I'm writing a 4, and then I have a 6, and then I do the math. 4 times 6 is 24, check. Okay, so I found the value of x that makes the equation true, and it's 4 units. All right, so let's look at some other shapes, right? This is an Oyo, so I want you to try these on your own. But first, of course, we want to talk about, well, a parallelogram has a base times a height to find the area, and a triangle, remember a triangle is half of a rectangle, so we take the base times height and we multiply by half or divide it by 2. So you should go ahead and pause the video and try these two on your own and then check your answers. Okay. So area equals base times height, and this is my base and this is my height. So I'm going to say they gave me the area of 20, so I plug in 20 for A. The base is 5 and the height is x. From my balance scale, I'm going to look at the side with the variable and undo multiplication by dividing. So I divide both sides of the equation by 5. 20 divided by 5 is 4, and 5 divided by 5, remember, just cancels out to a 1. So I get 4 equals x. So this is another one where x equals 4 units. And then I'm going to check by substituting in the value of 4. So I get 20 equals 5 times 4. And then, of course, I want to do the math on the right side, even though it seems silly. You're trying to prove that the left side and the right side are equivalent. And that's how I know that the value of 4 makes the equation true. You have to do all the math on both sides. Okay, let's look at number 2. This one is a little tricky because there is this 1/2. I typically use base times height divided by 2 like that. So I am going to the area, so this is area equals. And instead of the A, I'm going to put in 28. So I write 28 equals, this is my base, and this is my height. So instead of the base, I'm writing 8. And then the height is my unknown x, so I have 8x over 2. Now remember last week we looked at undoing two operations. What I can do is I can multiply by the reciprocal of 8 over 2, which is 2 over 8. So if I multiply this side by 2 over 8, then I need to multiply the left side by 2 over 8. And remember, I put the 28 over 1 because this side I'm multiplying fractions. And this side there already was a fraction. And then I look at all the things that cancel out. So my eyes kind of go over to here. I notice I can cancel out the numerator, denominator, numerator, denominator. And now I want to simplify before I multiply. And I can say that 8 goes into, well, I'm looking for a common factor to divide out of the 8 and the 28. And they're both divisible by 4. So 28 divided by 4 is 7, and 8 divided by 4 is 2. Now I have a 2 in the numerator and a 2 in the denominator, so I'm going ahead and cancel. I'm going to divide by 2, and that leaves me with just a 1 and a 1. So when I multiply across, I end up with 7 times 1 over 1 times 1, right? 7 times 1 over 1 times 1, which just equals 7. So I get 7 equals x. So this one is x equals 7 units. But I'm still going to check my work because this one was a little more complicated. So I rewrite the original equation, 28 equals. I have my base of 8. And so I'm going to do 8. But now I know my height is 7. So I'm going to plug in 7 divided by 2. Now I'm going to do the math one step at a time. 28 equals, first I'm going to do the multiplication. 56 divided by 2, and 56 divided by 2 is 28, so I end up with 28 equals 28. Check. All right, so now we're looking at, I didn't put a red star next to this. I'm not making you write this down, but when we define a variable, right, we're picking our own variable. First, we look at the question and say, what are we trying to find, right? Then we choose a letter for the variable, and then we tell everybody what the variable stands for, what x is, or a lot of times they say this, let x be, which means the same thing as x is. So we're going to try this with the word problems, and the first thing we are going to do is define our variable. That means you're going to tell everybody the variable that you're using and what it stands for. So when I look at this question, and notice these are also in the Record and Practice Journal, it says 3 robots go out to lunch, and they decide to share the $11.91 bill evenly. How much does each robot pay? So to define the variable, I need to look at the question, right? It says, how much does each robot pay? So my variable is sometimes I pick a letter, so I could put P for pay or M for money, so something like this. I could say M is how much each robot pays for lunch, right? You can picture these 3 guys sitting down and splitting a bill. So this was the total bill. So now we have to think about how are we going to write the equation if we know that the total bill was $11.91 and it's split evenly between each robot. So what I want to think about is there are 3, right? I'm circling the number 3. There are 3 of them. So if each one pays M, my equation is 3M equals 11.91. Now I'm going to solve. I'm going to draw my balance scale. I look at the size of the variable. I'm undoing multiplication by dividing both sides by 3. Remember that 3 divided by 3 is just a giant 1. It cancels out. That leaves me with a solution of M equals, I'm going to put a dollar sign in front of it because it's money, $3.97. Now when I check it, I plug it back into the original equation. So I have 3 times 3.97 equals 11.91. You could get a calculator and show me that you're using a calculator, or you can just practice some long multiplication. 7 times 3 is 21, 9 times 3 is 27, plus 2 is 29. Regroup the 2, 3 times 3 is 9, plus 2 is 11. Okay, that worked out. So I get 11.91 equals 11.91. Check. So this is what we're going to do in our word problems. We're going to define the variable, write an equation, solve it, and then check it. Okay, let's look at the next one. Here's some more robots. On Earth, objects weigh 6 times. Okay, so there's the 6 times. I'm going to circle 6 times what they weigh on the moon. A robot weighs 96 pounds on Earth. What does it weigh on the moon? So I'm trying to figure out what the robot weighs on the moon. I'm going to define my variable as W. W is robot's weight on the moon. Robot's weight on the moon. That's what I'm trying to figure out. So I decided to let my variable be W. Now here's where you have to figure out, are you multiplying or are you dividing? And so if a robot weighs 96 on Earth, it says that is 6 times more. So I'm thinking about the is 96. 6 times what it weighs on the moon, and we just let W be what it weighs on the moon. So it makes sense to say 6W equals 96. There's my equation. I solve it. I do the balance scale. I look at the side of my variable. I'm undoing multiplication by dividing by 6. My 6's cancel out. I end up with a solution of W equals 16. And then I want to make sure I put in the units, and it was pounds. So this robot weighs 16 pounds on the moon. And then I'm going to check my work. So 6 times 16 equals 96. Again, I'm going to do the math. 6 times 6 is 36. There we go. 96 equals 96. Check. Okay, so these are a little more challenging, but let's try these. At maximum speed, a robot runs 6 feet in 1 second. How many feet does the robot run in 1 minute? So that's what I'm looking for, right? How many feet in 1 minute? So I could call my variable F. F is how many feet a robot runs in 1 minute. Okay, so here's my equation. So they're basically telling me you could think of it as using a conversion factor, right? And so if they run 6 feet in 1 second, I want to think about whether I should multiply. So remember, I'm thinking about 1 minute is 60 seconds. And so I'm trying to figure out if I need to figure out how fast it runs in 1 minute, do you think I should multiply by 60 or divide by 60? So what I'm going to do is I'm going to take my the number of feet a robot runs in 1 minute, and I'm going to divide it by 60 because I know there's 60 seconds in a minute, and this has to be equal to 6. You guys might have been thinking, well, you just take the 6 feet and you multiply by 60, but then it wouldn't be really solving an equation. It would just be doing math on one side of the equal sign. So if you thought of this, right, F equals 6 times 60. I like the way you're thinking, but this is going to give me an equation that I can solve. Okay, so I look at the equation and I undo division by multiplying. So I'm going to put parentheses around both sides, and I'm going to put times 60 over here. Notice that 6 is a whole number, so I don't need to turn 60 into a fraction. But over here, I'm turning 60 into a fraction over 1, and then the 60s will cancel out, leaving me with F equals, oops, looks like I almost put a decimal in there, but it's not a decimal. It's just a 6. 6 times 60 is 360. And then remember, it is feet. Okay. So it totally makes sense. If it runs 6 feet in 1 second, you multiply it by 60 and you get 360 feet. Let's go ahead and check it using the equation that I came up with. F over 60 equals 6. Now I'm going to plug in the 360 divided by 60 equals 6. Now remember when I'm dividing, if I have a fraction and the numerator and denominator both end in 0, I can simplify by dividing out of 10, which means I'm just getting rid of the 0. If I divide this by 10, then this by 10. And now it's easier to see that it's 36 divided by 6, which is 6. So I write 6 equals 6, check. Okay, the next one. We have 4 identical robots that lie on the ground head to toe, and they measure 14 feet. That means you picture this, right? There's 1, there's 2, there's 3, and there's 4. And this total distance is the 14 feet. Each robot is not 14. The question is, how tall is each robot? So if I could call my variable h, and h is the height of a robot, right? And they're all the same. So if you think about them all being the same, you could take h plus h plus h plus h, which is the same thing as 4h. So my equation is 4h equals 14. I draw my balance scale. I divide both sides by 4. I end up with a decimal of h equals 3.5. And then the units, I go back and make sure I have my units. The units are feet. Okay, so now I'm going to check by plugging in the 3.5 equals 14, and I'll go ahead and do the math. 1 decimal place, 14 equals 14, check. Okay, so this is an OYO. You should read the question, define your variable, write the equation, solve it, and check it. And go ahead and pause it, do the work, and then check back in and see how you did. Okay, so notice it says you and 4 friends, right? So I'm circling the you and 4 friends by tickets. The total cost is $70. So if it's me and 4 friends, that means there are 5 of us all together. Write and solve an equation to find the cost of each ticket. All right, so for this one, I think I'm going to use C. So C equals the cost of a ticket. And remember, all the tickets would have to cost the same, otherwise we really couldn't figure it out. And I am going to say, if I bought 5 times C, that would equal 70. I'm going to draw my balance scale. The opposite of multiplying is dividing. The 5s cancel out. I get C equals $14. So the cost of a ticket is $14. And then I'm going to check my math. 5 times 14 equals 70. 27. Okay. I get 70 equals 70. So the word each, right, makes me think of sometimes it could be multiplying, sometimes it's dividing. But if you're buying multiple tickets, then you're multiplying the number of tickets times the cost. Okay, here's an OYO. This time you might want to think about the area model and a rectangle. And that's I use a theater example just to get an idea of the rows and columns can be like the length and width of a rectangle. So a theater has 1,200 seats. Each row has 20 seats. Write and solve an equation to find the number of rows in the theater. So go ahead and pause it. I think I'm going to use n for the number of rows. That's what we're trying to identify. So I'll say n equals number of rows. And let's see. So if I look at it like this, right, if each row has 20 seats, so here's all the rows in the theater, that means there's 20 seats and there is n number of rows. And when I multiply the 20 times n, I know it equals the total of 1,200. So I can put my 1,200 inside kind of like the area. My equation is going to be 20n equals 1,200. I draw my balance scale. I divide both sides by 20. Remember, I'm going to get rid of the 0 here. That's dividing by 10. Now I can see that 120 divided by 2 is 60. N equals 60 rows. Let's go ahead and check our work. 20 times 60 equals 1200. 1200 equals 1200. Okay, so here's a couple more examples. If you want to just pause each one of these and check and see if you're understanding, these get a little bit complicated. There's 2 more, and then, sorry, this is an example and then an OYO. So I'm going to do this one with you, and it's the next one you're going to do on your own. So you eat 8 blueberries. You eat 8 blueberries, and your friend eats 11. There are 23 blueberries left, right? You should be thinking about kind of that's a remainder. That's what's left over. Write and solve an equation to find the number of blueberries in a full package. So I'm going to use B as my variable. B equals, the number of blueberries in a full package, right? So that's a new package. So I like to kind of start with what I should have started with, right? If I think about a full package, I'm thinking that there's a certain number of blueberries left, and that's what I want to have on the other side of my equal sign. So if I start with an unknown number of blueberries, I'm eating 8 and my friend's eating 11. So we're subtracting from the package. So I could put the 8 plus 11 in parentheses together. Now you could do B minus 8 minus 11, but I like the idea of counting how many we ate together and subtracting that. So the remainder is 23. So there's my equation. Now, of course, the first thing I would do is what's inside the parentheses, right? So I'm going to simplify. So now I'm simplifying already, and my equation is B minus 19 equals 23. You might have started with this, but I really want you to start with this or start with that to show me that you understand that there are 2 things happening, right? That you and your friend are both eating from the package. Okay, I'm going to draw my balance scale. The opposite of subtracting is adding, so I'm going to add 19 to both sides. Those cancel out, leaving me with the number of blueberries equals 12, regroup, 42. So there was 42 blueberries in the package to begin with. And then I will check my answer. Oops. Let's not do B, let's do 42. 42 minus 8 plus 11 equals 23. Right, I go back to my original equation. 42 minus 19 equals 23. And now I'm going to do the subtraction. You should always use a calculator or check it. Don't just tell me that the left side equals the right side because you believe it should. Check. All right, so now we're on to penguins. Look, there is a cute little rockhopper penguin. This is the rockhopper. This is the emperor penguin. It is a very tall penguin. In fact, they say this penguin is 45 inches tall, and it is 24 inches taller than a rockhopper penguin. Write and solve an equation to find the height of a rockhopper penguin. So I already know that I want to use an R. R equals height of rockhopper penguin. Now again, this is where you're going to have to figure out, does it make sense to add or subtract? And when it says height is, I'm thinking I'm going to start with 45 is the height of the emperor penguin. And it is 24 inches taller than a rockhopper, which means I would take the rockhopper and I would have to add 24 inches to it to make the height of the emperor. So I'm adding the 24 inches. That's kind of the picture they're showing you here. I take my r plus my 24, and it equals the emperor's height. I draw my balance scale, the opposite of adding 24, subtracting 24. I get 21 equals r. So I know the rock hopper is 21 inches. And now I'm going to check my work. 45 equals 21 plus 24. And when I do the math over here, I get 45 equals 45. Check. Okay, now I have one more example and one last OYO. So you see the balance scale picture here, and I want you to think about the left side and the right side being balanced. And then what I want you to notice is, well, it's kind of weird. There's a 5x plus a 3x, but there's another 5x plus 18. Well, if you think about it, when we take things away from the balance scale, as long as we take the equal amounts from both sides, the scale remains balanced. So what if I did this? Because there's two sets of variables over here, that's really confusing. But I noticed that the 5x and the 5x, there's one on the left side and one on the right side. So how about this? What if I just take 5x off of the left side and I take 5x off of the right side? I have to get rid of the black marks because I don't want you to think that I am dividing. So there's my balance scale. I'm going to subtract 5x from over here and subtract 5x from the right side. Those cancel out, leaving me with 3x on the left side and 18 on the right side. Okay, so now you're saying this looks like a regular equation that has one step. So this is 3x equals 18. Now all I have to do is draw my balance scale and divide by 3. Those 3's cancel out, and I get x equals 6. Now here's the thing. This is what gets really tricky. You know how I said when you check, you have to use the original equation? So now this is going to look a little bit different than what you've seen before. When I take the x equals 6, I have to plug it in. Everywhere there was an x, I'm putting in 6. So now it's a little more complicated to do the check, but we can do it. Okay, so now I can start doing the math. 5 times 6 is 30, plus 3 times 6 is 18, right? We're using order of operations. We're doing multiplication first. And then I go over here and I do the same thing. 5 times 6 is 30. Oh, check it out. I can see that we did get the right solution. Excuse me, of x equals 6. I have to add the 30 plus 18, and I get 48 equals 30 plus 18. Again, is 48. Check. Okay, so just don't be too confused if you see that there's two sets of variables. If it's the same variable and coefficient on the left side as on the right side, you can get rid of it, and then you'll have a sort of the equation that looks like you're used to seeing it. Okay, I'm going to erase this to give me room to show my work. Okay, so here's the OYO. So go ahead and pause the video and try this one on your own. I'm going to move this over. All right, so we have the same idea. There's a lot of interesting things happening here in this equation. I can see there's 8y plus 2y equals 2y plus 40. They both have 2y, so it makes sense that I could just get rid of the 2y on both sides, right? As long as I do the same thing, I still have an equivalent equation. And now I have 8y equals 40, so I can draw my balance scale, divide both sides by 8. The 8's cancel out. I get y equals 5. The tricky part is putting it back into the equation. I have to write the whole equation as it was, showing that I am substituting in the value of 5. Everywhere you see y, I'm writing 5. And then I do the math. 40 plus 10 equals 10 plus 40. Finally, I end up with 50 equals 50. Check. Okay, so those are some word problems and some solving equations that are a little more complicated. Good luck on your homework today. Bye-bye.